Hi girls, let's talk about matrix multiplication on page 5 of your noties. Now, unlike a matrix addition, you don't necessarily have to have the same order for both of your matrices to multiply them together. To add two matrices together, they must have the same number of rows and columns, but it doesn't necessarily have to be the case when we talk about multiplication, but they must have something in common. Now, on the bottom of page 5 there, this first, by way of explanation, this line. To find the product of two vectors A and B, you've got to take elements in matrix A and multiply them with corresponding elements in matrix B. And once you do that, you add them together with similar other values. It's pretty similar to what you did last term when we did scalar, the scalar product of two vectors. We take the x coordinates of one vector and the x coordinate of the other vector, we'd multiply them together, then add them with the corresponding y coordinates. So it's a similar sort of thing. To determine if you can multiply two matrices together, you have to look at their order. If you have a matrix A and a matrix B, and you want to know, can you find the product A times by B? Okay, you have to note this. Okay, if A has the order m times by n, so it's got m rows, n columns, and B has order np, so n rows and p columns, you can find the product of these two vectors A and B. What do they have in common? Well, in M, the first matrix, it must have the same number of columns as B does the number of rows. If you can do that, then you can multiply these matrices together. Now, by way of explanation, rather than going through what this line means, let's do an example and then I'll explain a bit more over the page. Okay, I've got matrix A, I've got matrix B. What's the order of matrix A? It's a 3-row by 2-column matrix. And B, well, that's a 2-row by 5-column. So according to what we've just said, we can multiply these two matrices together. And why is that? Because A has 2 columns and B has 2 rows. I can multiply them together. And the thing is, by doing this little schema, putting down the order of both A and B together, I can also work out the dimensions of the product AB. Okay, so I can multiply them together because 2 in the middle is the same, number of columns in A is the same as the number of rows in B, and what's the dimensions of AB? Well, I'll just go around that. You'll never guess. Dimensions of AB is 3 by 5. Where does 3 and 5 come from? The number of rows in AB is 3. It's the same number of rows in matrix A. It has 5 columns. That's 5 is the same number of columns that's in B. So if I was to write out B in just dot form, what would it look like? Well, according to what we've just said, it has 3 rows and 5 columns. So altogether there would be 15 elements to this matrix. So 1, 2, 3, 4, 5. 5 elements in the first row, 5 elements in the second row, 5 elements in the third row. 3 rows, 5 columns. Now, how do we find the first element in our product? Well, if I was to take the position of this first one there, the first one, would we all agree that that is first row, first column? So that represents the position 1, 1 in the product 1, 1, in the product AB. So to get that first position that's in the product, first row, first column, I take the first row of matrix A. Okay, I'm going to take the first row of matrix A, and I'm going to multiply it through the first column of matrix B. I'm going to take that row, and I'm going to multiply it through the first column of matrix B. So what does that look like? Well, that would mean taking 1 position element 1 from the first row of matrix A and times it by the first element in the column of matrix B. So that is 1 times by 0. And then I keep going. I take 2, which is the second element in the first row of A, and multiply it by the second element in the column, in the first column of B. So that is 2 by -1. Add them up, simplify them, that would be -2. But that tells me that the first in the matrix AB, the product of AB, the first position, the first element in the first row, first column would be -2. Excellent. Only 14 more to go. Now, if I was to take the second element there, okay, would we all agree that is the product? In the product AB, that's in position second row, first column. Second row, first column. So that means I'm going to take, this time, the second row of column, so second row of matrix A, and I'm going to multiply through the first column of matrix B. Second row, first column. Second row is from matrix A, first column is from matrix B. So I'm going to take second column and multiply it through, second row and multiply it through first column. Second row, first column. Okay. So what's that going to look like? I'm going to take the second row again, which is 4. I'm going to multiply by 0. So that 4 is the first element in the second row of matrix A. Times it by the first element in the first column of matrix B, all by 0, plus 3 times by -1. That gives me -3. That -3 represents the element found in the second row, first column of the product. Second row, first column, -3. And we just keep on trucking, doing exactly the same thing that we just did. So, next bit. So next, this, moving on, go to this last column, last point there in that column of my matrix, my product. Okay, that dot there would represent the product AB in position third row, first column. How do I get that element? I need the third row of matrix A and times it through the first column of matrix B. So here we go. So here's my third row of matrix A. I'm going to multiply it through the first column of matrix B. So again, what's that going to look like? So that would be taking -2 and multiply it by 0. And add to that 0 times by -1. So again, I'm after the third row, first column in my product AB. I'm going to take the third row from A, -2, 0, and multiply it through the first column of B, 0, -1. That will be -2 times 0 plus 0 times -1. That would be 0. So back to my product. The third row, first column would be 0, etc., etc., etc. Now, rather than going through all the others, I'll write down. Now, let me write down how I get these ones. So, next point along. So, if I wanted to go to the first row, second column, I'll take the first row, second column, and go 1 by 3 is 3, 2 by 2 is 4, that is 7. And then 18, and then -6, and then 8, 22, -8, 6, 19, -8. Okay, let me just go through the last column. So this 7 there. So that's 7. So that 7 is in the first row, 5th column. First row, 5th column. So to find the first row, 5th column in my product, I need to take the first row from my first matrix. So again, to find that 7 there, which is on the first row, 5th column, I need the first row of matrix A and the 5th column of matrix B and multiply it through, like we do when we do the scalar product for vectors. I take 1 times by 3, that would be 1 times by 3 plus 2 times by 2 gives me 7. That's where 7 comes from in the first row, 5th column. Now the second row, 5th column is 18, I believe. Where does 18 come from? Well, 18 would be found in the second row, 5th column of my product. To find that, I would need the second row of matrix A, second row, and multiply through the 5th column of B. So that's 4 by 3. That's 4 by 3 plus 3 by 2. That gives me 12 plus 6. That is 18. That's where 18 comes from. And the last element in my matrix is in the third row, 5th column. And I think it is -6. How about we check it to see? So that is in the third row, 5th column. I think it's -6. How do I get it? Well, I take the third row this time of matrix A, which is -2, 0, and multiply through again the 5th column of matrix B. So first row, 5th column. That's -2. That's -2 by 3 plus 0 by 2 gives us -6. That's where -6 comes from. Easy. Again, to find any point or any element in the product, you need to find its position. You take the row number from the first matrix and multiply it through the column number of the second matrix. Now let's go over the page. By way of some more explanation, let's go through this. So in the previous example that we did over the previous page, A and B, what are the dimensions? Well, A has dimensions 3 by 2, 3 rows, 2 columns. B has dimensions 2 rows, 5 columns. What do they have in common? Well, the number of rows, so the number of A columns, the first matrix, which is 2, equals the number of B rows, also 2. As long as that happens, so if you write down the dimensions of your 2 matrices, if they share the same middle numbers, then you can multiply them together. So in this case, 3 by 2 by 2 by 5, you can multiply them together. And once you do that, the other numbers will tell you the dimensions of your product. So if I have a 3 by 2 times by a 2 by 5 matrix, I can multiply them together because they have the same number of columns in the first as rows in the second. And what's the dimensions of the product? Well, I just use the other values to work them out. 3 will be the number of rows in the product. 5 will be the number of columns in the product. Where does the number of rows of AB come from? Well, that's 3. it comes from matrix A. So 3, it equals the number of rows in matrix A. And where does the number of columns in the product AB come from? Well, it's 5, and it comes from the number of columns. Comes from the number of columns in B. Make sense? Here's a biggie. If two matrices can be multiplied together if the first has the same number of columns, we'll get this right soon, columns, as the second has rows. For two matrices A with order m times by n and B n times by p, the order of AB is m p. I know I can multiply them together, A and B, and they will have the order MP. Now again, it's not going to work, well, rather, we know that in normal multiplication, 3 times 4 does equal 4 times 3, but that doesn't necessarily mean that they are swapsies over in matrices. AB may not work if you swap them around. For example, in this case, if I was to go BA, so we know AB works. AB will have 3 by 5. Can I find the product BA? Well, BA, if I swap around, would be 2 by 5 times by 3 by 2. Can I multiply them together? Survey says no. Okay, B's got 5 columns. A's got 3 rows. They're not the same. You can't multiply B times by A. You can swap them around. A times B works. B times by A does not. Let's look at this example. I've got these matrices. So matrix A has dimensions 2 by 3. B has 1 by 2. C has 3 by 1. State if the following are conformable, and if so, what are the dimensions? Conformable just means can you do it? In the first case, can you find the product BA? Well, we'll just slap down the dimensions. 1 by 2 for B. Can I go 1 by 2 and times it by matrix A, which has dimensions 2 by 3? Answer to that would be a big fat yes, we can. Let's tick. Yes, we can multiply them together. And what will be the dimensions of the product when we do get it? It would be 1 times by 3. 1 times by 3, both 2 in the middle, we can do that. What about AC? AC, A, in order AC, A has dimensions 2 by 3. I'm timesing it by C, which has dimensions 3 by 1. Can I multiply them together? See the 3 and 3 in the middle? First one has 3 columns, second one has 3 rows. Yes, you can multiply them together. And what will be the dimensions of this particular matrix? Okay, there's the 2 and there's the 1. It will have dimensions 2 by 1, 2 rows, 1 column. BC, okay, B has dimensions 1 by 2, timesing that by C, which has dimensions 3 by 1. Can you multiply them together? First one's got 2 columns, second one's got 3 rows. This time, no, we cannot multiply them together. That's a big fat no. No point finding the dimensions because they don't exist. It doesn't multiply together. What product would have dimensions 3 by 2? Looking on my list, I need a 3 by 2, so I need something that starts with a 3. And the only one that starts with a 3 there is the 3 by 1 option. Now, can I get a 2 out of those? Well, the only one that has a 2 at the back is B. So that's 3 by 1 by 1 by 2. Will they go? Yes, they will. First one's got 1 column, the second one's got 1 row. We can multiply them together, and the dimensions, when we finally get there, will be 3 by 2. That's the one we're after, 3 by 2. And what is that option that gives us 3 by 2? That is CB, the product CB. All right. So did you follow what we just did? Okay, we're going to do a couple of examples here using matrix multiplication and following the rules that we just did. First one, we've got a matrix 1, -1, 0, which has dimensions 1 row, 3 columns. And the next one has dimensions 3 rows, 2 columns. Can I find that product? Well, yes, I can. 3 and 3 in the middle, yep, we can find it. And the dimensions of the product when I get it will be 1 by 2. So it has 1 row, 2 columns. Now, if I was to put that as a little dot form, I'd get something like this. 1 row, 2 columns would just simply look like a matrix that looks like this. Okay. I've got 2 elements. How do I find each of them? Well, this first one here, I'm sure you'll all agree, is at position 1, 1. First row, first column. First row, first column. So that means I'm going to take the first row from the first matrix and multiply it through the first column of the second matrix. So that will give me 1 times by 3 plus -1 times by 0 plus 0 times by 1. Gives us a grand total of 3. So that's my first row, first column. So 3, first row, first column. Now the next one is in the second column. So first row, second column. So I'm going to take the second, so I'm going to take the first row from matrix, first matrix, and multiply through the second column of the second matrix. So we're going to take 1 times by 1, add that to -1 times by 2, add that to 0 times by 4. That gives a grand total of -1. So my first row, second column value would be -1. And that's how we get the matrix. Taking the columns, taking the rows from the first matrix and multiplying through the columns of the second matrix. Cool bananas? Let's go to the next one. So over the page, we've got these 2 matrices. What are the dimensions of these? So the first one has dimensions 2 by 5. And the next one has dimensions 5 by 1. Sweet. Can we multiply them together? Yes, we can. What's the dimensions of the product going to be? It's going to be 2 by 1. All right, let's draw something that looks like 2 by 1. So 2 rows, 1 column only. 2 rows, only 1 column would look like this. Only 2 elements again. It's going to be easy. All right, to find this first element, which is in the first row, first column, I'm going to take again the first row from my first matrix and multiply it through the first column of the second matrix. Okay, that's going to be 1 times by 1, which is 1. Add to that 0 times by 2, which is 0. Add to that 4 times by 3, which is 12. Add to that 2 by 4, which is 8. And finally, add to that 0 times by 5, which is 0. Okay, that gives us a grand total of 21. Alright, what about the other element there? Okay, so the other element is in the second row, first column. So I need to take the second row from my first matrix and multiply it through the first column of my second matrix. So that would be 2 by 1, which is 2. Add to that 1 by 2, which is also 2. Add to that negative 1 by 3, which is negative 3. Add to that 1 by 4, which is 4. And add to that 2 by 5, which is 10. So I think that's a grand total of 15. There's my product, 2115. Looks pretty easy once you do it, eh? Maybe not. So the next one, and the last one. So what do we have here? So we've got a 2 by 2 matrix. I'm going to multiply that by something which has 2 rows and 5 columns. Can we multiply them together? Hell yeah. What's the dimensions going to be of my product? 2 by 5. Okay, let's do a little rough schema for our product. So I need 2 rows, 5 columns. 2 rows, 5 columns. So I'm going to have 5 elements in the first row, 5 elements in the second row. 10 elements all together. Yuck. Okay, let's cut to the chase. Okay, first point will be a first row, first column. So I'm going to take first row, first column. So that's 1, 3 by 1, 2. That will be 1 times 1 plus 3 by 2, which is 1 plus 6, which is 7. Okay, the number underneath this one here will be second row, first column. So take the second row from my first matrix, multiply it through the first column of the second matrix. That's 2, 4 by 1, 2. That's 2 by 1, which is 2, plus 4 by 2, which is 8. That is 10. Okay, up to the next one. So trying to find now the first row, second column. First row, second column would be 1 by 3 plus 3 by 2, which is 9. Okay, finding the second row, second column. Second row, second column would be 2 by 3, which is 6, plus 2 by 4, which is 8. 6 and 8 is 14. Next along, we've got the first row, third column. First row, third column is 1 by 0, plus 3 times 7, which is 21 altogether. Okay, one underneath would be the second row, third column. Second row, third column would be 2 by 0, plus 4 by 7, which is 28. Next, we got first row, fourth column. First row, fourth column would be 1 by 3 plus 2 by 3 is 6. That's 9. Underneath that, we'd have the second row, fourth column. Second row, fourth column would be 2 by 3 plus 2 by 4 by, sorry, 2 plus 3 plus 4 times by 2, which is 6 and 8 is 14. Nearly there. Next up, we've got first row, fifth column. First row, fifth column is 1 times 0 plus 3 times 1, which is 3. And the final element in my product is in the second row, fifth column, taking the second row from my first matrix and multiplying through the fifth column of my, taking the second row of my first matrix and multiplying through the fifth column of my second matrix. I go 2 times 0 plus 4 times 1, which is 4. There we have it. And that's how we do matrix multiplication. Again, all depends upon the order of your two matrices that you're multiplying together. If they share the same number of, if the first matrix has the same number of columns as the second does rows, then yes, you can multiply them together. And when you get the product, the number of rows that you will get in the product comes from the number of rows in the first matrix, and the number of columns in the product will come from the number of columns in the second matrix that you're multiplying them together. All right, girls, hope that helps. We'll see you again soon. Bye.